and open up for our next panel discussion and our first panel for the day, which is going to be about the future of Gen AI, what's up next for SLM training and serving. Our panel today is really a set of distinguished folks across open source models and research in LLMs and efficient architectures, here to be able to talk about what we view as being the future of Gen AI. I'm joined by a stellar crew, which I'll briefly introduce now. Pablo, distinguished scientist and research manager at NVIDIA. Lubna, the lead of the small LM team at Hugging Face, so very relevant for SmallCon. And Diego, who leads Gen AI partnerships for the Llama models at Meta. Thank you very much to all the panelists for being here today. I'll moderate today's session and direct some questions to one or two of you and some questions to the entire panel. For questions that are going to the entire panel, feel free to jump in as soon as you have something that you'd like to be able to say. Two things I want to acknowledge right off the bat. One, we only have 45 minutes for the session. Each of you individually deserves your own 45 minutes, so we'll be very tight on time. But it is an opportunity for you to be able to share kind of your direct views. And the second thing I want to just acknowledge is panels sometimes are difficult. People are still getting their feet underneath them by the time the panel ends. I'd suggest let's keep this as engaging for the audience. Feel free to give us your hot takes and really be kind of and share kind of your opinions as directly as possible. Now, with all of that said, I'll dive into the first set of questions. If anyone in the audience does have questions they'd like to ask to the panel too, please use the Q&A tab and I'll review those to try and ask them as well. Let me open up with my first question for Diego. Earlier this year, it was reported that Alphabet, Amazon, Meta, Microsoft, they're likely to spend over $200 billion in AI. Mistral has raised hundreds of millions of dollars for efforts in training and open sourcing models. I think all the developers in audience here are very grateful for the investments that your organizations have made in Gen AI and that you're open sourcing. But tell me a little bit about what you view as the benefit of open sourcing models and how that plays into maybe commercial strategy for you both as a company. Maybe Diego, if you want to take that first in terms of benefit for open sourcing AI and why Meta is investing so heavily in there.
Yeah, definitely. Thank you so much for inviting me. So to answer your question, we think that the value creation is not going to be definitely at the LLM level. So the way to actually increase access to these models is by making them available to everyone. And Meta specifically is using Llama models across the family of apps that we have, for example, on WhatsApp, on Instagram, on Facebook, to create generative AI experiences that in itself are more like at the application level and applied, and they're increasing engagement with our users and specifically working with the actual mission of the company, which is improving human connection. So at the end of the day, the strategy behind Llama is maximizing adoption so that everyone has access to the latest models. They contribute to them, they make them better, and Meta itself also has access to those.
I want to bring in Pablo and Lubna into the conversation as well. And Pablo and Lubna, both of you lead cutting-edge research teams, in particular around efficient model architectures, either small model training or net new architectures that would expand from everything from vision transformers to language. To me, it felt like just a few years ago, models like BERT were the ones that were considered heavyweight overall, and the large kind of tool set to use. And now we have models that are on the order of 1 trillion parameters, redefining what we think of as large models in general. Can you tell me a little bit about, just even for definitions, what do both of you consider a small model? And what do you think are some of the compelling reasons that what are some of the compelling reasons you think that people should be using small models and why you have decided to dedicate your time to the research of small and efficient models? Maybe, Lubna, I'll let you go ahead and tackle that first on definition of small models and why that's been a research area of interest for you, and then I'll go to Pablo.
Sure. Yeah, I think we usually consider a small model that can run on device, so basically on your laptop, but also your mobile phone, and with a decent latency so that it's usable and the users don't have to wait for a long time before they get an answer. So I think usually these models have less than 3 billion parameters or 4 billion parameters for them to be really fast to run. And I think the reason these models are becoming popular is that right now we have models that are small enough, but also really good and can give you decent generations. And we also have the right hardware to run these models. And also we have techniques like quantization and compression that allow us to make these models small, because BERT was considered a large model, but now it's really small and it's really fast to run. And the reason we're trying to focus on that is basically because we really believe that now there are a lot of use cases where small models can be good enough. And maybe in some use cases, you don't really need to use GPT-4 or Claude. Like it's really enough to take a small model and specialize it on your task, and you would get like really good generations. And also the other reason is that these models can run on device. So it really solves the privacy and security issue where your data basically stays locally. So I think that's like a big motivation for people to consider using small models, and also for research labs to like invest a lot of time into developing these models.
Thank you very much, Lubna. And I actually love the on-device nature and the use cases. I feel like it's something that folks have been asking for a while. I remember a year ago thinking like, almost no way. Like, can these generate tokens at a reasonable rate? But that's significantly changed over the course of this year. I think in large part due to the contributions from the Hugging Face team. Pavlo, maybe the same question to you. How do you think about small models overall, and why has that been an area of research that you've been focused in, like overall in efficient architectures?
Yeah, I think for small architectures, we're looking for some kind of, the smaller, the better models that can still reliably solve some tasks. And for criteria, we'll potentially look into like inference efficiency, size, and quality. So on inference size, as Lubna mentioned about quantization, so if we, let's say, take 1.5B model, quantize it with 4 bits, it will be roughly 750 megabytes. Plus, you're going to add some cache. And if your entire model going to be 1 gigabyte or less, that's something great for SLM, because then you can run it on device, but at the same time, you can run other applications. So, right, in terms of GPU, you might want to use this model during in-game experience. So you still need to do rendering. You cannot take entire GPU for a single model. And also in terms of quality, I think we are with really exciting times. Like last year, Llama 2 was released about summer, right? And it had like MMLU around 45. And nowadays, we just released a Hamba model 1.5B last month, and it can achieve MMLU about 50. And so we see this, right? In 1.5 years, the model can get 4 times smaller and still kind of reliably solve tasks, also be nice to chat with, so on and so forth. So I think even for next years, we will have even smaller models. Yeah.
Pavlo, Luna, I want to ask you a follow-up question, which is oftentimes when I work with organizations, they have a lot of questions about what model should I use for my style of task? And in particular, can a small model do well on my task? And sometimes the tasks are open-ended, sometimes they're a bit more specific. On device is a clear use case for small models out of necessity. But even as we think beyond on device, are there any particular types of tasks or use cases or properties of tasks that you think make them particularly adept for small models overall? Maybe Pavlo, I'll let you answer first, then Lubna, if you want to chime in too.
Yeah, I think small models are really great for some tasks like rephrasing or summarization. We use small language models for in-game experience, for example, to make it more immersive, like dialogue generation or scenario generation, and it really sees it's quite amazing. And you cannot use large model because again, you will want to run something else on the GPU. So I'll say anything that doesn't require like very specific knowledge, world knowledge, I think these models are really great.
I'm curious, is there any like application that for maybe the small LMs had maybe something that if there was anything that surprised you that they did particularly well at? Anything that comes to mind there?
Yeah, I think in addition to what Pablo mentioned, like rewriting summarization, these are tasks that the models are really good at. I think another task where the models are surprisingly really good is like text extraction. I think they're really good at like extracting information from text. And there's like this company called NewMind, which even took the model and further fine-tuned it on the task on like their internal data. And the model was like close in performance to Llama 70B, which is a huge. So I think like for some use cases, you can fine-tune a small model and get like really good performance.
Yeah, wow. I mean, that's incredible actually to hear because the size differential in terms of the overall footprint is like significant on that side. Diego, maybe a similar question over to you. Meta has released variants in every size from 1, 3, 8, 70, 90, 405B. How do you think about like the strategy both there, and are there any kind of examples of any sort of examples or guidance that you think about for users as they think about what model selection to use from Meta's broader family?
At the highest level, it's not necessarily like an either or. It's very much that these models complement each other in different ways. and they could be used in agentic applications or orchestrated in one way, but they also feed into each other. For example, through synthetic data generation, so that you can fine-tune other models to expand your existing data sets so that they're even better for a specific tasks. I think when it comes to agentic applications, there's obviously a lot of benefits of small models, which can be run in personal computers, personal devices that are better. And then if the agent determines that the prompt or the query that it has to go through is more complex than it's supposed to for like a small model, say like an 8 billion parameter model, then it could go to a bigger model. I think there's a lot of potential for improving the function calling, particularly as we make these agents actually autonomous, so that they interact with other tools that are out there. And that in and of itself is another cool way that these models are gonna continue to get better at. And I think both big and small would work together.
Yeah, Diego, you brought up two things I want to double click in there. One of them is around agentic workflows. The other is going to be around fine-tuning and training. Let me dig into the agentic workflows piece first, and I'll open this up to anyone on the panel that wants to sort of take it. Agentic workflows feels like it has become the theme of Q4 2024 in Gen AI. And what people, if people said that 2023 was the year of prototyping, 24 is the year of production, feels like 25 is like the year around agentic workflows. I'm curious if anyone on the panel wants to define what they like, if they want to provide a definition for what they think is an agentic workflow, and then their view of whether or not agentic workflows will be something that become commonplace in 2025 or something that we're just going to be scratching the surface of. I'll open this up to anyone on the panel that has maybe an opinion on agentic workflows.
Yeah, I think with agents, it's actually quite interesting that we do really need them. Like we can do these tests of trying to multiply floating point numbers with even like Llama 70B model, and we will see that sometimes it's gonna fail, right? It might be due to tokenizer, or might be due to the fact that we are trying to teach our LMs to memorize things instead of like reason about them. But on the same time, if we have LLMs that can use tools and can use, for example, a calculator, even a 2B model can really, very easily multiply these numbers. And I think for this agentic future, we really want to look in cases when these tools will be called during the generation. So something that even user doesn't notice, right? Like we, for example, need to do some math, and this calculator usage just happens behind the scene. We have no idea about it being like even called. And same will happen for many other tasks, like if we need to look some fact, we can very quickly search with a hash through Wikipedia and find some information. For example, I usually like to ask small models about French Revolution, because I think that was like a very important factor in the history, right? And we can find this and summarize a page in Wikipedia instead of trying to force our model to learn these facts. And we know that small models really struggle with hallucinations. So yeah, for agentic future, most likely we're gonna have tons of very small models that are specialized, and these small models can be even sub 100 million parameters. And ideally for the user, it should not be even aware. So everything should be in context. I think one of the issue right now with evaluation is that, especially for function calling, that's usually single prompt, single instruction, and the output is a single function. But we really need to go to space where you will require multiple tools within single generation. Yeah.
Lubna, Diego, in case you had any comments on agents, I wanted to make sure that you also had a chance to be able to chime in. But I will just maybe interject by saying my view is that one of the biggest limiters towards agents has actually been probably around efficient model architectures, because I think what you end up needing is these subsequent chains of calls that can do things like self-reflection, correction, and the subsequent, for example, tool calling. And for production applications today, that would get either very slow or quite expensive if you're operating at high throughput. So I think the work you all are doing is very relevant.
Yeah, that was
Go ahead,
what I was gonna say. So the thing is that most of the models that exist today were trained on the open internet, and if you think about it, the result of what the internet is the final outcome that humans published after a lot of reasoning, but the reasoning was not published. The drafts were never there. Like, you only see the final work of the book that was published, but the drafts didn't make it. And that's exactly what chain of thought is. And ultimately, a lot of it is going to be synthetic and amplified with the little that we do have. But that's exactly where you're kind of teaching the model. I don't know if anyone saw it, but this week, Meta released a research paper on chain of reasoning thought. They basically argue that instead of converting from embeddings to actual language for reasoning, they basically actually researched their brain, which is pretty cool. And they realized that the language part of the brain, when we're reasoning, does not get activated. So the way that translates to LLMs is we don't have to decode and pass to language and tokens and then recursively pass it on again to the model. Let's just do a more continuous set of reasoning. So yeah, it's still in research, but pretty cool. We're basically building a human brain.
Yeah, it's always interesting. I feel like probably 25 years ago, 30 years ago, it's like neural networks had become an architecture, taking inspiration from the brain. There was a fad moment where it was a very cool application of like human biology, but a lack of realization of how to be able to make it applicable to real world kind of examples. And I think like one of the most exciting things that's really happened post 2014 was like the rise of like deep learning, like neural network and deep learning architectures to be able to do more and more and actually take some of that biological inspiration. I do think two things were mentioned with respect to agentic workflows. One of them was around model efficiency and efficient architectures. The second was around data. And actually, both of these are questions that I think about a lot, in particular when people are training their own models, either fine-tuning and doing some amount of kind of incremental training, or just training even from scratch. And I wanted to go to Lubna on this one. You released the small LLM small model series, and I think really impressive to see just the best in class models across parameter size ranges from like a few hundred million to I think 1.7 billion. And I'm curious to hear a little bit about two things. The first is you were trying to train a small model to be particularly effective at general purpose benchmarks, which is somewhat counter to the narrative I think people generally have had, which is like if you want general purpose capabilities, go larger and larger. So I'm curious how you thought about the dataset side of that and also the challenges that fed into it. And if you can give us any sort of intuition behind what were the biggest lifts that came in the training of the model, any kind of key things that you learned or takeaways from training the small model LM series. And maybe you can introduce the small LM series in your own words when you start the answer, just for folks that might be less familiar.
Yeah, of course. So Small LM2 is like a model that we released almost a month ago. It's a series of 3 models, 100 million parameters, 300 million, and 1.7B. And each model is the best in its class category. And so these models are like good at like general tasks, but also at some specific tasks like tool call or summarization or rewriting. And to answer your question about like the role of data, I think one interesting thing you said is that like the general belief has been that larger models is the way to get like better models. But I think also larger data sets has been a thing for getting better models. It's just that we only focus on the model size parts and we forget the data size parts. So one trend that we have right now is to train smaller models, but train them on higher quality data sets and also train them longer. So that's basically what we did for our small M2 models. We spent a lot of time on like data curation. We ran a lot of experiments to compare the public data sets, and then ultimately we found the best mix to try to optimize these benchmarks that we cared about, which are like for knowledge, but also reasoning. And after that, we also trained these models for very long. So for example, our 1.7B model has been trained on 11 trillion tokens, which is really large compared to how long we used to train these models. So yeah, I think for us, like the key focus was like data. I think there's other ways to approach these problems. For example, for Pablo, I think their Hambar model was like more focused on the architecture, which was like mix of transformers and state space models. I think data is still like really important, and that's like what makes one model better than the other. And like usually if you look at like model releases, information about the data is missing because that's what usually gives the competitive edge. So yeah, I think that's how we try to get these models. What was your second question about?
I'll actually come to the second question, but because you you made a very interesting point. How do you measure data quality in training? Like you said, 11 trillion tokens. Very hard to go ahead and review some subset of that to know if it's quality or not. How do you think about ensuring it's high quality data that goes into it?
Yeah, so I think one way people try to do it is like maybe by intuition, try to come up with filters, but that doesn't really work. The only way to know if a dataset is good is to actually train a model on it. So when I say we did experiments, is that like we basically take different datasets and we train models on them. You don't need to train the model on 11 trillion tokens, maybe just a few 100 billion tokens. And then you evaluate the model that's trained on the datasets, on the benchmarks you care about. And then you compare which dataset give you the best model. And then that's the dataset you ultimately use. So there's a lot of compute and like training that goes into finding the best filters for the data you care about.
I love the small LM series because it also provides a really compelling on-device story as well. Like as you think about, where the trajectory of these small models can go. What's next for the small LM series overall? Like you published just a month ago, and you deserve like I think a little bit of a holiday over the break too. But I'm sure people are wondering, these model parameter ranges really performed best in class in like their size range. What's next? Is it exploring how to go even smaller, improving quality within that size range? How do you think about the future of research objectives here?
Yeah, I think we're always gonna try to compress the models and make them even better. And like Pablo mentioned, now we have models that are 1B, which match like models that were 13B from last year. So maybe the year after that, we're gonna match models that are even larger. And I think for the small M series, we're gonna try to make them multilingual because right now they're English only. We're also gonna try to have like a larger context and also support other features, maybe make them better at math, which I think is still something that small models struggle at. So yeah, these are like some of the things we want to focus on next.
Excellent. And maybe the final question, Luna, is do you anticipate that small LM will be predominantly used in a fine-tuned setting, or do you think it'll predominantly used as base models? Where do you anticipate most of the usage going?
Yeah, I think fine-tuning is like the main thing for small models because a lot of people try to approach them like large models and expect them to be good at everything, but that's not really the way to go. I think we're gonna move from just prompting models to actually fine-tuning them for our use cases. So yeah, I expect fine-tuning to be like main use case for these models.
Yeah, that's excellent. I'll actually use that as a segue over for Pablo. Pablo, I think that a lot has changed in deep learning from, let's say, 2016 to where we are in 2024. One of the larger changes that I think we've seen from like a data science and operationalization standpoint is kind of the rise of parameter efficient fine tuning. And so it used to be the case when 30 to 40 years ago we were talking about fine tuning, you almost exclusively meant a full fine tune. And today, I think that I'm curious to know what the metrics are, but the majority of folks that we talk to are probably doing the parameter efficient fine tuning style. Now, you were one of the authors of the DoRA paper, which if folks have not read it, highly encourage you to be able to look at. Kind of introduces an enhanced low rank adaptation technique that allows you to fine tune models at a higher average quality than other PEFT techniques like LoRA. I want to understand maybe and I want to dig into that. I want to understand initially, like, what's your opinion on the future and adoption curve of specifically parameter efficient fine tuning techniques? You hear everything from fine tuning is dead on one side of the category with long context windows to, hey, full fine tuning is the best way to go over techniques or like over LoRA. I'm curious what your opinion is on parameter efficient fine tuning and where that's going to go in the future.
Yeah, I think parameter efficient fine-tuning is very exciting, right? Because we can do that when we have very little data. That's one of the main reasons to use it, because if you're going to do full fine-tuning with very little data, we will have catastrophic forgetting, and model will lose a lot of its capabilities. And even in cases when we fine-tune SLMs for specific task, we still want to have some general knowledge, right? Like a very simple example, I played in games that had LLM inside SLM, and I just came to different characters, started talking about food and other stuff, and model needs to know that even if it's fine-tuned for something else. I think for PEFT specifically, we need to do a bit more research to understand what's going on there. That was the main idea behind DoRA. So it was like, okay, let's look what does PEFT do and how our weights look, and this is where we found some structure in the weights, and by decomposition the weight, we were able to do the fine-tuning a bit more efficient. So I think the future for PEFT is really to understand a bit more of what's going on during our normal fine-tuning and potentially try to replicate it with PEFT for cases when we don't have that much data.
Yeah, the sample efficiency, I think, for like PEFT is one of the primary reasons people end up using it perhaps over like having enough data to be able to go ahead and fully saturate like the training run of a model. I'm curious if you have a view on like where PEFT is likely to, or let's just say fine-tuning as a class of techniques is likely to go in 2025. Do you think that what's more likely is that organizations are going to do more PEFT fine-tuning with smaller amounts of data, or to be able to increase the data saturation, but think about ways that they can go ahead and compress the model architectures to take advantage of that, like increased data volumes? Like if you had to forecast through the end of like this time next year, I would say this time this year, LoRA and some advanced techniques like DoRA have become more common. What do you think will be true about parameter efficient fine-tuning 1 year from today?
Yeah, I think it's a great question. And probably for things like fine-tuning, you will also want to do this for a bigger model, for larger models. And then I think for next year, we should kind of forget about training from scratch and focus on compression or distillation. We had this Minitron work where, we showed you can save 160x by doing this compression, and your model is also greater. So I think for PEFT, it's completely possible that in next year we will apply it for larger models and then just compress it to smaller size. That still will solve the task. I think that's very possible because large models generalize even much better. You can even just do a couple in context learning examples, right, for them. Oh, I think just to add to this, about in context, or sometimes we have couple samples, we can plug them together for the prompt and the model will understand what you want, but that increases our context window, KV cache, and that becomes very expensive. So sometimes by even doing this in context, we can use PEFT to fine tune the weights and, do the expected work. And then we save a lot of efficiency in this case. So exciting time for PEFT, yeah.
Rather than jamming the examples into the prompt, you can go ahead and do like this parameter efficient fine tuning. I also find that models lose some of the, like with longer context windows, like models lose some of the actual cohesion around those, and quality does not linearly increase by increasing more examples into the prompt as well. One question, we'll end with two questions that can go to the entire panel. The first question I'll say is just earlier this year, we had a release that we called LoRa Land. It was a series of fine-tuned Mistral 7B parameters that we put out. And our goal was just to show small fine-tuned models actually can outperform prompting larger general purpose models. I think like 85% of our fine-tuned models beat GPT-4 on the evaluation set across 30 different tasks. I think even we were surprised at how viral LoRa Land went, hundreds of thousands of impressions and, lots of folks that I think were resharing it. And I think what it indicated to me was like, most people today still don't understand the potential for small language models, or they think that the small language model, like the delta in using a small model versus the large model, is going to be a significant hit on quality. What do you all, I'm curious, this is gonna be a question to the panel, you can jump in incrementally. What do you think is stopping users of large general purpose models today from adopting the small models? Is it time, or is there like a tooling roadblock that we need to address as an industry?
I think it's also like a question of time because we're just really starting to have models that are small and that's actually useful. And when you're gonna have more models, of course, you're gonna also have more tooling for using them. For example, now we have like a lot of frameworks to do on-device inference, like MLC, MLX, Llama, CVP, and all of that. So I think that's like something that comes naturally. And also people need to understand how to properly use these models, how to prompt them, how to fine tune them, and like when does it make sense to use a small model instead of a large model. And I think as we start to have like good models and people start to try them and like understand really their weaknesses and that like you should use them more for like some specific use cases and not as knowledge bases, I think this will like come naturally and people are gonna start like to migrate more towards these small models because they're gonna understand better how to use them.
Makes perfect sense. I'm going to end with one. Pablo, unless you had anything you wanted to add, I was going to end with one final question.
Yeah, I think we need to do a bit also more research about like generalizability of SLMs and task-specific fine-tuning. So probably some form of loops where a large model is involved, like as large as possible, 4 or 5B llama or even bigger. And so by providing a couple examples from the user, it will be able to, I don't know, generate more synthetic data and make sure that small language model also generalizes. So I think we need a bit more research in this area of, few shot kind of learning.
I'm very bullish on this idea we often refer to as a flywheel that Paul also brought up in the previous section of like deploy the larger model, use as a way to get like a 75% solution, collecting data, and then iterate on the data quality to Lubna's point to be able to fine tune a higher quality, smaller model from there. I'm gonna end with one final question. I feel like it wouldn't be a panel if we weren't asking for hot takes. And so I'd like to be able to ask each of you for either a hot take about generative AI today. And I'd say a hot take is something you believe that you think the majority of either researchers or practitioners would be surprised to hear, or a prediction about where generative AI will be by the end of 2025.
Yeah, I think we live in an exciting time with especially small LM corpus like data sets where we see the data is driven things, right? Like architecture doesn't change much, but because of better, higher quality data, especially for SFT instruction tuning phases, the models get better and better. So obviously we will see data improving, models getting better, but I also think that we need to redesign the architecture for small language models. It doesn't make sense to have a model and then KV cache of the same size. So we need to look into linear attention and other things. Yeah, so for SLMs, I really expect we're gonna dive deeper into architectures, at least on the research side. Yeah.
Diego, a hot take or prediction for 2025?
I think the way I look at the generative AI maturity where we're in is that it's just getting started. And I used to work at McKinsey before coming to Meta, and a lot of the work that I was doing was obviously with large enterprises. And when we sat on the meetings with C-suite, we ended up pretty much advising on like map out all the possible places where you can apply Gen AI and start from the bottom, the less risky, but also the less valuable ones. So you can capture learnings and figure out how to then go up in the ladder. And if you look at it, most enterprises don't really have external use cases. Most of them are internal chatbots for their employees. So once they capture their learnings, they're gonna start to go to another subset of use cases that are gonna actually start requiring access to more proprietary data. They're gonna want to control the models. They're gonna want to customize it. And this is my hot take. Right now, everyone is getting started on closed source models because they're really easy to get started with. And they're great because if you don't even know what you want, you can iterate really quickly, just pinging an API. Once you get to a point where your use case matures and you start applying the technology to something that's actually differentiated using the data you have as your competitive advantage, that's where open source models are going to come in stronger. But I don't think the market is there yet. And that goes for small and big models as well. That's my hot take.
Perfect. Lubna, would you be willing to finish our panel with
Yeah.
your hot take?
And I think in AI, we started like with fine-tuning models because they weren't really working and trying to make them for our tasks. And then we went to like prompt engineering them. And I feel like we're gonna go back to like fine-tuning them to make them even easier than just like prompting the models. And especially with all these questions about like privacy, which are starting to become like even more serious. And also if we want to open adoption for some sectors like healthcare or finance or where like data privacy matters. So I think, yeah, maybe like the prediction for 2025 is that like we're gonna go back to like fine-tuning models and trying to get them to work on like on device hardware.
Machine learning is weirdly cyclical in those ways
Yeah.
in terms of trends of what picks up. Thank you very much to the entire panel.